So challenge statements, there's always a question, how do you define them? Where do you choose to start? It's hard for companies, governments, even a profitable company can have will have challenge statements. They always want to improve outcomes for their customers and operations. You can't sort of rest on the same process that you've had over the last few years. So obviously within an AI tool, we always talk about solving a challenge statement. By solving that challenge statement, you reduce your cost, but more importantly, you actually increase the experience that you might have for all the stakeholders that interact with your company. It could be a supplier, it could be obviously a customer or a citizen. So typically what we have with systems and software that are implemented over a period of time, it can, so let's say if you take an ERP software, that's an ERP solution for obviously, let's say your manufacturing cycle. Once that software is in, you can wait for a long, for it to pay back on that software. It can take obviously a number of years, and obviously you're inventing new processes around it. But those new processes will still have challenge statements within those that can still be solved and improved. And especially with some ERP software, which you can't develop or change that much, how do you then take the data that you're gathering from that and then help that to improve your operation? So obviously with challenge statements, breaking them down is important, breaking them into subsections, and then looking at perhaps maybe 3 or 4 challenge statements that can be potentially solved by doing one action. That is also possible as well. So that also comes from data and good data set. What we have found, talking to our customers, talking to the organizations that we are working with, is that an initial digital twin is a good solver for this, because you have data sets, because you have access to external data as well. So you may have a factory that is affected by traffic or by weather or other external aspects. You can create a digital twin and then play different scenarios of what may happen. So that could be an initial starting point, where if the head of manufacturing creates a digital twin and there's a HR problem, basically manufacturing and HR can work together to try and solve, okay, this could be a route that the employees take which is not safe or not good, and you can work things out, you can model things out differently to see what is a better way to do that. You don't have to have a complicated digital twin. You can have a one-dimensional one, and you can run it you have 2-3 models. It doesn't have to be very complex. It doesn't have to run in real time. You can use a lot of the digital twins historically, based on your historic data, and then make different models and adjustments. You also have different ones where, like for instance in law enforcement, you need to do it in real time. So simulating something that is done in a process fashion over 6-7 days, we can now digital twin that process and say, well, okay, if we had reacted there and then, based on obviously an alert that had come through, how does that work? So you have to look at your challenge statement in a different way, and there are new technologies that can solve that, but it all starts from obviously perhaps doing a digital twin on your existing data set. So again, we'll have sessions and webinars over this, and hope to keep you informed on new ways to look at your challenge statements.